Hi there, everyone. Today we're going to be looking at lesson 7.7a, exponential functions. You will need a calculator for this. Woohoo! Calculator! All right, let's take a look at what an exponential function is. So maybe you want to pause this, or while I'm talking, go ahead and start writing, but it's going to look a lot like a regular exponential function. And remember, that's just y equals a times b to the power of x. The a is still the starting value, the y-intercept when x equals 0. That's still your a. That's your start. But in here, instead of seeing the letter b, we're going to see 1 plus a percentage, because here we're going to be seeing problems where we're dealing with growth. So the b is our factor of change, and it will be growth in terms of a percentage. Then the x up here is going to represent our time periods. Now, just to explain a little bit what this 1 is all about, think about if I were to write 1 as a percentage. So right now, this is the number 1 with a decimal point after it, but if I change a 1 into a percentage, I move the decimal 2 places to the right, and that would be 100%. So when we have something that's growing as a percentage, we have to first take 100% of what we already start with and then add the percentage onto it. So let's try a problem with the exponential growth function. Our first example is going to be about mosquitoes. Yay, your favorite thing in the summertime. So here we've got number of mosquitoes at the beginning of the summer was 4,000. And the population is expected to grow 25% a month. How many mosquitoes will there be after 4 months? We're going to use the exponential growth function because we see that there's growth happening at a rate of a percentage. Anytime you have a problem with a percentage where there's growth, you can use the growth model here. So it says y equals our starting value is a, and we're going to be multiplying it by the growth. And then the exponent will be the time periods. I'm just kind of copying this from right here. So let's put in what we know. We do know that the start of the summer was 4,000. And we're growing at a rate of 25%. When you put that in here, it needs to be written as a decimal. So decimal here, back it up, 0.25. So 1 plus 0.25. And then the time periods. Looks like we're wanting this to grow for 4 months. We want it to grow 4 times. So 4 is our exponent. Now I want to simplify this to show you something. Right here, 1 plus 0.25 would be 1.25. The number in here, if it's bigger than 1, that means that this is growth. Okay, we want that bigger than 1. Okay, then you're just going to use your calculator to evaluate it. You're just going to plug all of this right here into the calculator. Okay, my calculator says approximately 9765.6, so maybe that could round up to a 6. So about that many mosquitoes after 4 months if this is the growth. So we definitely see an increase there. And that's how you do it. Let's try another one. All right, your room is too cold. So you decide to adjust the thermostat. The current temp is 60 degrees, so we can see our starting right here. In an attempt to get it warmer, you want to increase the temperature 10% every hour. What would the temperature of the room be after 3 hours? So here we have our start, we have our growth, and we have our time period. So we're just going to plug that right into the function. Our start, our growth, and the exponent is our time period. So putting 60 degrees here, 1 plus 0.10 and 3 hours. So this will be 60 times 1.10 to the exponent of 3. And then you're just going to use your calculator to type that in and evaluate it. If you have parentheses on your calculator, just use the parentheses. Otherwise, you have to think order of operations. First take the exponent, then multiply it by the 60. My calculator says 79.86, so approximately 80 degrees. That's what it would be if I was warming up my room 10% every hour for 3 hours. There we go. See, kind of fun. Number 3, we've got 20 years ago, Mr. Huss purchased his home. Whew, he got a good deal. 160,000. Since then, the value of the home has increased. That's called appreciation. About 5% every year. So how much is the home worth today? So we have our starting value, we have our growth rate, because it's increasing, and we need our time period. Well, this says 20 years ago, so we want our time period to be 20. So let's set it up. Y equals, the A, of course, is the start, which is he started with a home that's worth 160,000. The growth will go in here. We want the 1 plus, so we're taking 100% of what it's worth now and adding 5%. So decimal point, 1, 2, back it up, back it up. Exponent up here, 20 years. So 20 years later, what will the home be worth? So this is what we're going to put in our calculator. Keep in mind here that in the parentheses, this is 1.05. Again, we see a number that is bigger than 1, which shows us its growth. I get that, which looks like answer C. That's what his home would be worth today. Ooh, nice job, Mr. Huss. All right. Number 4. Ooh. Yuck. Termites. This would be so much more fun if you were seeing this in class. This would be in living color. All right, so we have foundation of our house has termites. Oh my goodness. And the termites grow by about 2.4, so grow by about 2.4% each day. How many termites will there be after 2 weeks? Okay. Whew. Exponential growth. Here's our starting, our A value. Our starting here is 1,200. Our growth, 2.4% each day. That needs to be a decimal. Back it up, back it up. So 1 plus 0.024. And the exponent needs to be how many days? Remember, this is growing each day. And we have 2 weeks. So I can't put a 2 up here or it will look like 2 days. 2 weeks would be 14 days. So we want our exponent to be a 14. Now, if you add these two together, again, you see this is greater than 1. 14, we want the 14 as our exponent. This is what I'm going to type into the calculator, and that's going to tell me how many termites there's going to be after 2 weeks. My calculator is giving me about that. So it looks like approximately 1,672 termites. So it definitely grew from here to here. Yuck. All right, there we go. See, it's not growing very much, 2.4%. Not a lot, but still disgusting. Okay, moving on. Oh, much better. Money. Okay, here we're putting $500 into a savings account. That makes 5% interest. So we're growing our money because we're making interest annually every year. How many years will it take for your money to double? Ooh, how many years? Okay, so we have a starting, we have a growth, but we don't know the time. We're trying to figure out how many years. All right, let's start by maybe putting this into a function. Let's use this here. So y equals starting and growth, 1 plus percentage, back it up, and time. Don't know. Let's simplify. Time. Don't know. But we want our money to double. So the amount of money here that we want to have total in our account needs to double. If we started with 500, we want this amount of money to be 1,000. So we are trying to figure out how much time. So there's our x or our variable. Well, this is kind of like guess and check. How much time? I mean, so try it. Try putting in 2 years, 3 years, 4 years. I mean, with your calculator and see what amount of time would you need to put this money in the bank for in order to get $1,000 to double your money. So, of course, you're going to have to play around on the calculator. But because we're not in class together, if I plug in 14 years, it looks like my calculator says I have $989.96. Well, that's not doubling my money. So maybe if I put it in for another year, 15 years, I'll double my money. So I'm just going to hit the back arrow in the calculator, put in 15, boom, I have $1,039.46. So it looks like in order to double my money, I would need to keep it in the bank for 15 years. And I've doubled my money. All right? Cool. Figured it out. All right. 6 and 7. On number 6 and 7, we're given an exponential growth model. Do you see how they are both growth models because this number is bigger than 1 and this number is bigger than 1? And I'm asking you to tell me what is the growth. So here are the choices. Did you decide what you think? So remember that this comes from 1 plus the percentage. So in order for it to become 1.25, this must have been 0.25. So this right here tells the percent. And if I take 0.25 and change it back to a percent, it would be 25%. So hopefully you picked D. Try the second one. So right here, what's the growth? You think you have it? Okay. So remember, this came from 1 plus. Must have been 0.065. So this right here is the growth percent, 0.065. Right now it's a number. I'm going to change it back to a percentage, 1, 2 to the right. This would be 6.5%. So hopefully you picked C. See, that's kind of fun. So that's how you do that. All right, and that's everything. I mean, I think we went through everything, and I'm trying to rustle my papers around here, and so here it is. Hopefully it makes sense, and you guys can see how it's very much the same as the exponential growth function. It's just that the B, which is our growth here rate, is going to be a percentage. And so we want to be sure we use the decimal when we put it in there. And growth is going to be bigger than 1. All right, there you have it. Have a great day.